All right, we're just waiting for my PowerPoint to come up, and there we go. This is the how to do problem set G, the speed of light. Now, as with the speed of sound, the equation is very similar. Remember, and I said this before. Let me get my pen started. That we have this simple equation that the speed, this comes from the sound where velocity is equal to the wavelength times frequency. Now we just have a constant instead, which is wavelength times frequency, where the c is 2.99 times 10 to the 8th meters per second. And sometimes I want to point out that if they're using two significant figures, I got 3.0 times 10 to the 8th meters per second. And so I suspect that sometimes if you have any differences between the two answers, it's that the book sometimes uses 3.0 times 10 to the 8th instead of 2.99. So just to be aware of that. C, again, it's the speed of light. This is going to be wavelength. Now the wavelength must be in meters. If you have any other type of unit, you need to convert. So convert to meters. And F is going to be frequency. Usually that's in 1 over S or hertz, and this is the primary unit of frequency. So if you see frequency in 1 over S or hertz, you're in the right unit. Don't have to worry about it. If it's in minutes, you change it to seconds. Meters always convert to meters. So let's take a look at this. All right, so how does light with a frequency of this one and a wavelength nanometer, 545 nanometers travel? So we want to know, we're looking for the speed. So we're looking for the speed of light. We have wavelength, 545.00 nanometers. This is not in meters, we need to convert. And the frequency is 5.4999 times 10 to the 14th. And hertz is in the right unit. So we're going to put this all together. So we're going to go to my next one. C is equal to, I'm going to go back with wavelength of light. We've got 545 nanometers. For every meter, there's 1 times 10 to the 9th nanometers. That's my conversion factor. And if I come down here, that's going to be 545 times 10 to the minus 9th meters, or move this over, it'd be 5.45 times 10 to the 7th, negative 7 meters. So 5.45 times 10 to the minus 7th meters. We can't see this. And then we're going to multiply by the frequency. The frequency is this dude right here, 5.4999. That's hertz. And we're going to figure out what all this means. So get your calculators out, guys. So this time we're multiplying. 5.45 raised to the minus 7th times 5.4999 times, raised 10 to the 14th. And we have 2.9974 times 10 to the 8th meters per second. Meters per second. Whoops. All right, I lost my pen. That's what's happening. So what I want to do is, I'm doing meters per second. This tells me that this is in space, or this is in a vacuum. So this is the speed of light. All right, remember that C is equal to lambda times frequency. If you need frequency, divide by lambda. If you need lambda, C divided by frequency. You guys should be able to run all these.